Hello, experimental psych class. So we're going to now pick up on where we left off on Monday, November 18th. So this is basically what I would have been lecturing this Friday, 11/22. Okay, so we're going to finish up confounds and then we'll move on to chapter 14, replication and generalizability issues. So let's get to it. Okay, so we left off talking about some confounds that are a little bit more specific to certain types of designs between or within, or mixed designs depending on the variables. Right? So now we're going to talk about confounds that tend to be problematic for any kind of experiment because it's really inherent in any kind of methodology. So let's talk about our first one. We've got demand characteristics, for instance. So this is anytime a study contains cues to what the hypotheses are, right? And so this then alters your participant's response. So the person might guess the study's purpose and change their behavior in the expected direction. So this is problematic. This is what we call demand characteristics. Okay, so an example of this is an Orrin and Sheeb 1964 study where they did this kind of sensory deprivation study. So the study was supposedly about sensory deprivation, and they told participants they were going to place them in an isolation chamber for 4 hours. The isolation chamber was just a room with a desk and a chair in it. Okay, so they were leading people on to believe that this was about, sensory deprivation in some way. Half of the participants were told that there were, they were basically going to imply that they should behave in some kind of way, giving them this kind of information. So what they were told was they were given like a consent form, and the consent form had language that released the researchers from liability. They had a panic button in the room. They were asked questions about their medical history, like do they have a history of dizziness or fainting. They had a tray of emergency medical instruments. It was marked emergency tray and whatnot. And again, these are all items that might indicate that if you are in isolation for a prolonged period of time, you should act in these ways. You should feel dizzy, faint, panicky, things like that. Okay. Our control group, however, half of these participants, or the other remaining participants, were told that they were part of control group. They weren't given the consent form release where that releases researchers from liability, just a typical consent form. No panic button, no medical history, and there was no emergency tray in the room. Okay. So then both participants were exposed to the same isolation chamber, quote unquote, which is just a room with a desk in it. And they were told to report their experiences while they were in the panic room. So while they were in there, they would talk about what they were experiencing. Okay. So what happened? Well, the participants in the experimental group freaked out. They tended to show more extreme reactions. They reported more unusual perceptions or imagined activity. They thought the walls were starting to kind of like wiggle, waver. They thought that objects on the desk were coming alive, like the pencil and paper and things like that. Compared to the control group, they just kind of hung out and probably felt bored. Okay, so this is a nice demonstration of how expectations can really affect, or excuse me, the knowing about, sorry, knowing about the hypotheses to a study can really affect then what you feel like you should be doing or behaving. So for instance, this is why I don't do a whole lot of within subjects designs, and I have to surreptitiously manipulate defendant race. So any of you taking one of my studies, it would probably be problematic because you know too much about what I do. And so you would know if you read a case and I mentioned race, you might automatically think, oh crap, she's, doing something on race, and so I don't want to look like a racist, so I'm going to change my responses, right? As opposed to getting what people's true responses are when they're not aware of what you're manipulating. Okay, so demand characteristics can be a real thing, especially within subjects designs, but for both kinds of designs, when subjects really try to guess what's going on and then act in that kind of way, becomes problematic. Then we have observer, or sometimes called experimenter bias. Okay, so this is where the researcher's expectations, okay, our expectations influence the interpretation of the results. Okay, so this is really more where the researchers are having some kind of influence on the results versus what we saw with the demand characteristics. That's more what the participants kind of feeling like the way they should act. Right? So with observer bias, people might do things like code based on the expectations of the condition, or subtly convey different information or instructions to participants, and then that alters our results. So let me give you an example of this. Clever Hans was this kind of case back in 1907. And so this was occurring in Germany. So a school teacher by the name of William von Osten, he trained his horse Clever Hans to do math, math of an average like fifth grader. So he could add, 3 plus 2. So if he wrote down like here, add 3 plus 2, the horse would tap with his hoof 5 times the answer, right? So 3 plus 2 is 5. So the commands could be given verbally or written. So he could tell Hans, add 3 plus 2, and then he would tap 5 times, or he would write it down. So researchers could also get him to do math too. And so everybody thought that this was really great because not only is he able to do this kind of simple addition subtraction from his owner, he can also do it with other people who seemingly aren't involved in his life. However, Oscar Funks came around and he decided, well, okay, let's really test if this horse can actually do math. So he gives separate people separate parts of the math problem. Okay, so maybe he would whisper in one ear 7 to another person, one person, and then, another person would get +2. Right? So then people didn't know what the correct answer was. Only one person knew that they got 7, another person knew that they got 2. But adding those 2 together, you would get 9. So the right answer would be 9. So when you do this, and then you have Hans do the math, right? Where people are giving the separate math problems, then Clever Hans couldn't actually solve or wouldn't give the right answer. Okay, so what was happening was, because people knew the answer, one person would give the full equation, 7 plus 2, for instance. So they knew the answer was 9. So they were subtly changing their behaviors, like their posture, where they were looking. And Hans was able to detect these kinds of subtle changes in order to give the right response. So that people might lean in a little bit closer as he's getting closer to the right response, right? And then he would stop tapping his hoof when people maybe would smile or knew he was approaching the correct answer. So in fact, he was just a really clever horse in that he could subtly pick up these really subtle types of cues, right? So this is a good example of this kind of researcher expectation. So another example that we have is some maze bright and dull rats, which I'll play a video for you all to explain the Rosenthal and Fode 1963 study.
This is a man named Bob Rosenthal, and early in his career as a research psychologist, he did something very devious. Late one night, Bob secretly crept into his lab and he hung signs on all of the rat cages. Some of the signs said that the rat in the cage was incredibly smart, and some of the signs said that the rat in the cage was incredibly dumb, even though neither of these things was true. So then Bob brings this group of experimenters into his lab and says, for the next week, some of you are going to get these very smart rats and some these very dumb rats, and your job is to run your rat through a maze and record how well it does. So what did they find? It was not even close. The smart rats did almost twice as well as the dumb rats. Even though the smart rats were not smart and the stupid rats were not stupid. They were just all the same kind of average North Dakotan rat.
That almost to me sounds like the stuff of science fiction, like telekinesis.
Yeah. No one really believed him at first.
I was having trouble publishing any of this.
But what Bob eventually figured out was that the expectations that the experimenters had in their head actually translated into a whole set of tiny behavior changes.
Handling rats and handling them more gently can actually increase the performance of rats.
This kind of dynamic happens in people too.
You may be standing farther away from someone you have lower expectations for. You may not be making as much eye contact, and it's not something you can put your finger on.
That's Carol Dweck, a psychologist at Stanford. She was one of several researchers who explained all kinds of surprising things that expectations can influence, like teacher expectations can raise or lower a student's IQ score. A mother's expectations can affect the drinking behavior of her middle schooler. Military trainers' expectations can literally make a soldier faster or slower.
Think about that. As you go through the world, the expectations of other people are constantly acting on you, literally making you stronger or weaker, smarter or dumber, faster or slower.
Yeah. So my question was, how far does this go? So Carol, for example, if I expect that if somebody jumps off a building, they will be able to fly, that's not going to work out so well, right?
Right.
So what does science know about where we should draw the line?
That line is moving. As we come to understand things that are possible and mechanisms through which a belief affects an outcome or one person affects another person, that line can move.
Okay, so again, this is another example of how, and this kind of takes it a little bit further where people are actually now influencing the behavior of the person, right? But um, again, any kind of research expectation, right? Oh, we think that those rats are dull or they're smart. Then maybe if we're observing them, we might then code for those particular behaviors. We think, okay, well, this mouse is really smart, so you might just be more likely to look for, clever kinds of behaviors that they do versus not so clever behaviors, right? And then you ignore that and you don't code for it. So we have to be very careful about these kinds of effects. So some solutions to these demand characteristics and observer bias are things like double-blind procedures. Aha, so this is pretty, common lingo when people are talking about drug trials and stuff. There's this double-blind placebo study, whatever. Right? So all double-blind procedures mean is that neither the experimenter, the person who's running the study at that particular time, nor the participant know the condition assignment. Right? So in other words, if I was doing a study where I was looking at the type of interview given in an interrogation situation, and um, perhaps and getting false confessions and stuff, right? Then I, for instance, shouldn't know if my suspect is truly guilty or not guilty of the crime that they're being suspected of committing, like a cheating. So if you get participants to cheat or not to cheat, and I'm the interviewer that's going to try and interrogate them and know if they're guilty or not guilty, I shouldn't know if they did cheat or if they didn't cheat, if they're guilty or not guilty, right? And the participant should know what's going on. You might tell them that this is just an experiment on how well people work together in groups, and then they end up getting interrogated later, not knowing that that's the true purpose of the study. Right, so you want to use maybe double-blind procedures, or you can use the masked or blind procedure, and this just means that the experimenter doesn't know the condition assignment. So obviously, the participant's going to know what condition they're in, kind of. They're exposed to it. They're exposed to that condition. Um, and so, for instance, maybe you play a sad movie for them, but you want to make sure that the experimenter is not going to know what condition they've been assigned to. Maybe you're then coding their behavior after they've watched the movie. You don't want to know which movie they watched. So this is your master blind procedure. Okay, both of these can help with these demand characteristics and observer bias. Because if we don't know what to expect, then we have no expectation, hopefully. Right? So we can try and do this as best as we can. Then there are placebo effects, which the video before was giving us some kind of indication of a placebo effect. So placebo effects are when people who receive, a placebo treatment only improve because they believe that the treatment that they received worked, right? So you might randomly assign people to receive some kind of new drug therapy for depression, right? And so you tell them you could possibly be in the placebo condition or the control group, or you could be in the true drug treatment group. So they don't know. But if they truly believe that they are going to receive a treatment that's supposed to increase, or decrease their depressive symptoms and increase their mood, they might actually start to feel like something's happening. Okay, so to kind of demonstrate another way to look about this, there was another study done in 1994 by Pratkanis and colleagues. And what they did was they had participants listen to a self-esteem tape or a memory tape. Okay, so these tapes were supposed to either boost somebody's self-esteem or boost somebody's memory. Okay, like those kind of like self-help tapes, and you think that they work and they really don't. So half of the time, participants were told that they received the opposite tape. So for instance, they were given a self-esteem tape, but half of the time they were told it was actually a memory tape, okay? And vice versa. If somebody received the memory tape, half of the time they were told it was to help increase their self-esteem. Okay, so you've got 4 different conditions here. You've got people who actually got a self-esteem tape and people who actually got a memory tape, but some of those people who received the self-esteem tape thought it was supposed to improve memory, whereas some thought it improved self-esteem, and vice versa. Those who received the memory tape, some thought it was supposed to improve self-esteem, but others thought it was supposed to improve memory. Okay, right? So we've got SC, expected memory, got memory, expected SC, or they got SC, expected SC, got memory, expected memory. So what they measured were a couple of things. They actually tested them on self-esteem, right? So they measured their self-esteem and they gave them memory tests, okay? And then they asked them, their perceptions. Do you feel like it helped your memory? Do you feel like it helped your self-esteem? These are two very different things. Just because somebody feels like it helped them doesn't necessarily mean it actually helped them, right? So I know this is a little messy, but let me explain what's going on. On the y-axis, we've got actual scores of performance on either self-esteem or memory. And then these are the 4 various conditions, right? So people got the self-esteem and expected that it would improve their self-esteem. They got the self-esteem tape but expected memory. Got a memory tape but expected it would improve self-esteem. Got memory but expected it would improve their memory. Okay, so we've got 4 different conditions. These are their scores on self-esteem and their scores on memory, the purple and the green bars. So no matter what condition they were in, these tapes didn't matter. See, these tapes weren't going to improve, self-esteem or memory regardless. So in other words, across the conditions, if people got, let's say, the self-esteem tapes, right, you would expect their self-esteem to be better than the other people, but they're not, and that's fine. But again, alternatively, when you look at people who got self-esteem and they expected the memory, that also didn't really improve their memory scores. Memory tapes didn't improve that. Okay, so in other words, even the expectation here isn't really changing people's scores. And so sometimes, right, this doesn't affect actual scores. Placebo effects tend to affect people's actual behavior. But when you ask then, what is the, percent that you thought that the tape actually helped? When people actually received, like they expected to the tape to help their self-esteem, and they asked, did this help your self-esteem? Well, more often than not, they were saying, yeah, that totally helped with self-esteem and not memory, regardless of the condition they were in, regardless if they received the self-esteem or the memory tape. And conversely, if they expected memory, they expected that to help. Okay, so people's expectations can be influenced. But with placebo effects, the results can also change. Okay, so people receiving a placebo might actually see real increases or decreases in depressive symptoms, let's say, and this might just be a result of because they expected it to help. So now let's talk about some problems that might make your results null. In other words, reasons why you might find that you have not found significant differences, and maybe you were expecting them, but they're not there. So this means that there might be some low variability between groups. Okay, so if you think of a between group subject, or when you're comparing the two means, that means the variability between those two means, right, is low. So the two group means are very similar. Okay, so you've got low variability between groups, and this is what null results are. The means aren't differing that much, and so you have null effects. So sometimes, if we find no difference between groups, it can mean a couple of things. Maybe there's really no effect, and there could really be no effect, right? Second, your dependent variable, your measure, right? We talked about construct validity, could lack reliability or validity. It's not consistently measuring what it should. It's not a valid measure. It's not actually measuring what it's intended to measure. And so you're going to find null results because there's so much variability in the scores that you're never going to find any kind of differences because they're not consistent. Another thing we haven't talked about yet that comes along with this confounds lecture is maybe your manipulation didn't quite work out as planned. So for instance, if you're looking to manipulate sadness and you want to keep people in a control group or make people sad, maybe your manipulation isn't strong enough, right? And so this can be problematic, but we'll talk about that. Okay, so let's talk about a couple of things. You can get ceiling or floor effects because your dependent variable might not be really picking up what you intend it to pick up. So for instance, let's say you were looking at stereotype threat and math performance. So for example, if let's say women are given the stereotype or are in a room full of males and they activate the stereotype that men are better than women in math, this can actually decrease their performance on a math test and thus have an effect. So in our conditions, maybe they're in a room full of males and that activates a stereotype for them, or they're in a room full of females. And then you give them a math test, right? So you would expect them to find when they're in a room full of males, they should perform more poorly on the math test than when they're in a room full of females. However, the problem becomes where your dependent variable isn't sensitive enough, and it can cause the groups on either of the levels of the independent variable to score almost the same on the dependent variable, right? So if you give a bunch of easy math questions, like you say, okay, we're going to do stereotype threat, but all the questions are like 2 plus 2, 3 plus 5, 8 times 2, right? That's highly easy to solve. Most anybody can do that without a calculator, right? So then everybody's going to do really well. These are called ceiling effects, where everybody scores really high, okay? And so this can also be if the manipulation is really high. Everybody's kind of, really, really sad or really, really happy, right? So in this instance, it's more so that the math questions are way too easy. In this other example, you can get floor effects when people all score really low or your manipulation is really low, right? So if you start giving like calculus examples for people to solve, most people probably couldn't solve those pretty easily. Let's say if they're in their early 20s, college age, right? That's a little bit more difficult. And let's say you're not given a calculator. So you start to get people who score very low on the exam, regardless of what condition they're in. Because even if there was a difference between these two groups, you can't see it because people, we don't have a test that's sensitive enough to capture what people's average skills are, right? So you have these problems of ceiling and floor effects. Right. So another example to give you something more about how you can see how not only the dependent variable can affect these ceiling or floor effects, but an independent variable. Let's say that you wanted to see if when you give someone money, that affects how likely they are to, contribute to a charity later on at some other point in time, right? So let's say you give people, half your group 25 cents, and you give your other half of the group $1, right? These amounts of money are so low, this might not affect their willingness to give to a charity later on, right? Or maybe be helpful in another kind of situation. So you have to you have to have a manipulation that discriminates well. So you can give people money, like you give somebody a quarter versus you give somebody $50, right? And that might affect their willingness to maybe help or pay it forward in another task later on. And so that's how you can get maybe some of these ceiling and floor effects due to poor independent variable manipulations, right? Same thing with if you give people shocks and you want to measure their anxiety. And so, if you give somebody shocks that are way too high, no matter what in either condition, you're always going to elicit high anxiety. So, solutions to this, what you all, I hope, did before you submitted your materials to me for this study, you should always pilot test your materials. You should always pilot test them, no matter what. I do this, my research assistants do this, graduate students I've worked with do this. We always develop our materials and then do a dry run through, and then we also test them with other people. Okay, so we do it in multiple phases because sometimes our eyes might not catch these problems, and also we can do it on a smaller data set to see if we're getting differences that we expect. So you might want to, examine the effectiveness of your manipulation and also how well your scales are doing prior to the experiment. So are materials understandable to people? Do people understand your instructions and what to do? So for instance, I've been hearing a lot about a study where, here on campus that people are doing for credit for SONA, and people get a code at the end of this. And some of my students keep asking me, what do I do with this code? And I'm like, I have no idea. I'm not in charge of the experiment, right? So it might be that one, people aren't reading instructions, which is highly likely, or two, the experimenter didn't give instructions of what to do with this code after. I don't know which one it is. I suspect the former, but um, you have to make sure that everybody understands what you're trying to do step by step if you're doing it online, in person, things like that. Are the levels of the variables appropriate, right? So again, if you're manipulating, how much money you're giving people, is this enough of a discrimination to count as you give them a small amount of money versus a large amount of money, and then you measure some kind of helping behavior afterwards, right? Um, so these are some kinds of issues to think about. Then also when you think about your dependent variables, you have to go back to construct validity. Are your measurements valid and reliable? Are we making sure that, they're measuring what they intend to measure and they consistently do so, right? So if you're assessing mathematic ability, maybe you give people some SAT questions and you give them some kind of mid-level SAT questions, and we know that those are measuring math performance. So some other things you can also do to check your independent variables and make sure they're doing what they're supposed to be doing is do something called a manipulation check. So what'll happen is during an actual experiment, you actually kind of throw in another dependent variable, sort of, but this is checking to make sure that your independent variable is doing what it should be doing, right? So at the end of the study, I might ask my participants what was the race of the defendant, right? And so I want them to know what the race of the defendant is, but I also kind of have to make sure I'm not eliciting any kind of demand characteristics and making race too salient to them, unless that's my manipulation. And so I might ask them at the end, what was race of the defendant? Then they check off from, or type in their answer. And so this helps ensure that they were paying attention to the race of the defendant, because I'm predicting that this would affect their verdicts, right? Maybe after you make them play some kind of game that frustrates them, that makes them angry, you then have them take the PANAS, which is the positive and negative affect schedule, right? It's a scale that determines their current mood state. And so you can check if after the manipulation, they experience this kind of increase in anger, right? So it can be explicit, or implicit. Maybe you're trying to increase people's prejudice by showing them an angry video, and then you give them the implicit association test, the race IAT. And then you see, okay, did this video increase their IAT scores, right? And so this might be a good manipulation check. you should be putting these things almost right after the manipulation. Sometimes that's not always possible. Like I won't ask people right after a trial, hey, what was the race of the defendant? Because they haven't given me my verdict yet. So sometimes I ask a little bit after. Things like mood, sometimes it's best to do it right after because you have to know how they're feeling currently. Okay. And so what you can do is, mathematically speaking, is you can do some analyses for this, right? So you use, well, before I go on, I'll say this here. What you can then do is you then use your uh, excuse me, you then either kick out people based off of their response to your manipulation check, like what was the race of the defendant, right? If they didn't get that right, kick them out because obviously that manipulation didn't work. You can also, if you're inducing people into different mood states, let's say you make half your participants angry and half of them sad. So then afterwards, you give them the PANIS, you give them a scale to measure their mood, and then you do some t-tests and you say, okay, were people in the angry condition more angry than the people in the sad condition? You have both those conditions anger scores, and then you test that, and then you say the same thing for sad, right? So you use these to check your manipulation, right? So sometimes if people, let's say you're trying to make people sad or angry, and you then measured their PANIS, you measured their mood, you measured how they were feeling angry, sad, happy, etc. If your manipulation didn't work as expected, so then you didn't find differences between your happy, or excuse me, your sad and your angry group on anger or on sadness, then instead you can replace your manipulation, your condition with the, with the PANIS, with the measure of mood. So now you might then ignore what condition people are in and you just measure what their current mood state was. And so then you can get the more angry people and see if that predicts your outcome, right? Stereotyping or, increases in prejudice, whatever it is. And so now what happens is your results are going to be an association claim. They're correlational because you're now using a measured variable, what their current mood state is, to predict your expected outcome. Are they stereotyping more? Are there increases in prejudice depending on their mood, right? So this is correlational because it's measured to measured. We're not using the condition anymore. So sometimes this happens when, your manipulation was weak or there are just too many individual differences. And so you get that high variability within your group. Okay, so now let's talk about, so, if you think about that, that was all low variability between groups, right? So your two conditions weren't different enough for various reasons. Now you can also have no results when you're expecting significant differences due to high variability within a group. Okay, so we're going to explore that. So think about within one condition, people's responses are so variable on the dependent variable that you're not going to then see differences between that group and another one. Okay, so a couple things can be going on here. Real quick review. This brings us back to some measurement issues. Sometimes we have what we call non-systematic error, right? So we've got systematic error, which could be some confounds, but then this non-systematic error is noise or what we call random error. So this can be that you have bad measures or questions, you have individual differences, like there are people who are higher in extroversion, neuroticism, agreeableness, their moods can be highly variable, and the situation. There's a noisy space, the room's really cold, and this might affect your results, right? And so just to take a really quick side trip also into thinking about these situations, let's take a quick trip down reminder lane of power. Right, so power is your likelihood of correctly rejecting the null hypothesis. So probability of detecting effect if an effect exists. So that's usually determined by how big is that effect? Is it something that's highly impactful? What's the sample size? The bigger it is, the more reliable cross-section you have of a population. Typically, that's not always the case. It also matters how you select your participants, right? The alpha level you set. If you have a large alpha level, 0.10, you have a less likely chance of finding significant differences between your group. And this last thing is reducing noise, this kind of measurement error, individual differences, and situation noise. This will help increase your ability to detect effects if they exist in the population. So, you know, it's important that you try to make sure your measure is actually measuring what it tends to measure. Otherwise, people within groups, within that one condition, are going to be so highly variable, you're not going to detect any kind of effect. And if people are highly variable within a group in terms of individual differences that are important for predicting, this will also be problematic for your power. Okay, so let's talk about different ways you can change or manipulate your independent variable. So for instance, if you wanted to, my apologies, didn't mean for that to happen quite yet. If you wanted to maybe affect people's mood, you could do so environmentally. So you might play, one type of music to elicit more happiness or maybe neutralness. So let me play that for you now, which is Mozart. Okay, or maybe you want a more somber kind of tone. Okay, right, so you can kind of elicit mood environmentally speaking, playing a video, playing some kind of music, having them listen to it for a while. You can also do things like use confederates, right? So maybe you have a confederate who does something that they, to make you cheat or to make you feel angry, to irritate you, right? So these are environmental types of manipulations. Other things you can do are maybe giving instructions. So you can if you want to induce different kinds of motivations, whether like how people are motivated, you can tell them, well, this isn't a test of your ability versus this is a game. And so this might elicit different kinds of things. If you tell them it's a game, then they might take it less seriously, right? Versus a test of ability that's going to motivate them to try and do their best, right? So these are different ways that you can kind of manipulate things. I do this a lot with instruction because I'm maybe manipulating the race of the defendant. So they're surreptitiously being effective. And there are also more invasive types of manipulations like doing surgery or drugs. So let me give you an example of a study where we have all three present. So Schachter and Singer were testing this two-factor theory of emotion. So they basically we're testing this idea that two things kind of happen when you encounter a situation that then elicits an emotional response. Your sympathetic nervous system is going to be aroused, and so you experience actual arousal, physiologically speaking. Your heart starts to race, your blood pressure, goes up, and then your brain interprets that physiological sensation as emotion. Okay, so what they did was they gave participants a shot of epinephrine, okay, or a placebo shot. Okay, so epinephrine is adrenaline. It should increase your blood pressure, heart rate, your blood flow, and your breathing. Okay. So then half of the time, participants were given instructions that the epinephrine shot that they were given, right, and some were given a placebo, that would, they would actually experience, the effects of epinephrine, palpitations, tremors, they'll feel flush, faster breathing. The other half were told nothing about the shot. They just said there would be no side effects. Okay. And then they popped them into this environment. And so half of the time, participants were in an environment with a Confederate, and that Confederate acted a couple of different ways. So the Confederate acted either kind of euphoric, like they were really happy, they're playing with a hula hoop, jumping around and stuff, and enjoying themselves. The other half of the time, the Confederate was angry, throwing couch cushions and cursing. Okay, so you can kind of see all the various ways that they were manipulating various factors. And what they were really trying to figure out was, are people interpreting this arousal as an experienced emotion? And would this then be impacted by, what other people were doing at the time as well? Okay. All right. And that's the end of that. So just kind of a summary is when you think of these null effects, and confounds in general, but we were talking mostly about the null effects just in this section. There's no effect in the population. It can be due to things like measurement error, weak manipulations, so you have a lot of between group or less between group variability. You might have some within group noise going on, and so that becomes problematic, especially decreasing your power. So the more you can decrease these kinds of external noisy factors, like making sure the room's not too cold or there aren't other environmental influences going on, will help increase your ability to detect your effects and thus, finding the differences between these groups. So we will continue on in the next video with problems of generalizability and replication.